So today we're going to take a look at how we would solve an equation that has more than one step involved. So when we do this, we're going to actually have to use order of operations backward. That kind of makes sense because when you're solving a problem, you do order of operations the way we've learned it, parentheses, exponents, so forth and so on. So when that's when you have all the numbers and you're solving the problem, but now you kind of look at it, we know the answer and we need to find the numbers used to get that answer. So we're doing really the opposite, so that's why we're doing order of operations backwards. So when you guys are used to thinking of parentheses, exponents, multiply and divide left to right, add and subtract left to right, and you're used to doing order of operations that way, we're going to switch and we're going to actually do it backwards. So we're going to actually no longer do it forward. When you're solving equations, you have to work backwards. If you're just solving a problem, you do order of operations the way we've always done it. If you're doing equations, though, you have to do it backwards. So let's go ahead and take a look at the first problem. 2n minus 1 equals 5. So we want to solve this equation. We're going to work backward in order of operations. So we look first for any subtractions or additions. And we have that. We have a minus 1. So we're going to start by doing the opposite of minus 1, which is to add 1. So we're going to add 1 to the left side of the equation and add 1 to the right side of the equation. When we do that, this plus 1 and minus 1 are going to cancel each other out, leaving us with just 2n. So we have 2n on the left-hand side, and we have 6 on the right-hand side, because 5 plus 1 is 6. So now we look and we have 2n equals 6. Now we need to get rid of a times 2. The opposite of times 2 is to divide by 2. So we're going to divide by 2 on both sides of this equation. Times 2 and divided by 2 are going to cancel each other out. And we're going to be left with n equals 6 divided by 2, which is 3. And if we were to go back and check that, we're absolutely correct because 2 times 3 plus 1. We want to know, does that equal, or excuse me, 2 times 3 minus 1. We want to know, does that equal 5? So we look at it and following order of operations going the way we're used to this time, because we're not solving the equation, we're solving the problem. 2 times 3 is 6 minus 1. 6 minus 1 equals 5. So both sides of our equation do in fact equal 5, which means we are correct. N does in fact equal 3. Let's look at another example. So looking at this, actually let's look at this one. 22 equals 4 plus 6t. So looking at that, we're going to first say, well, we have an addition where we have the plus 4 and we have a times 6. Order of operations backwards, we're going to get rid of additions and subtractions first. So we need to start by subtracting 4 from each side of the equation. The plus 4 and the minus 4 cancel because they're opposites. And we're left with 6t on the right-hand side of the equation and 22 minus 4, which is 18 on the left side of the equation. Now we need to get rid of the times 6, so we're going to divide by 6 on both sides of the equation. So when we do that, we're going to divide by 6 here, divide by 6 here. 6 times 6 and divided by 6 cancel each other, leaving us with just t equals 3. 18 divided by 6, which is 3. And if we go back and check, once again, we're going to go back and check. 22, does it equal 4 plus 6 times 3? 6 times 3 is 18. 18 plus 4 is 22. So we do in fact find that 3 is the solution to our equation. Looking at another example. R over 7, remember that means R divided by 7, minus 2 equals 0. So we're going to do what first? We're going to get rid of the subtraction first. The opposite of minus 2 is plus 2. So we're going to add 2 to both sides of the equation. When we do that, the minus 2 and the plus 2 cancel. That just leaves us with R over 7 equals 0 plus 2, which is 2. And then we're ready to get rid of the divided by 7. The opposite of divided by 7 is to multiply by 7. So we're going to put a times 7 here, a times 7 here. Times 7 and divided by 7 cancel, leaving us with just r equals 2 times 7, which is 14. And if we want to check that, we will do 14 over 7 minus 2, and we want to make sure, does that actually give us 0? So 14 sevenths, or 14 divided by 7, equals 2 minus 2, and 2 minus 2 does in fact equal 0. So we are correct. R does equal 14 in this particular equation. I'm going to do 2 more examples. Take a look at it and see if you know what to do first. So you might want to pause it, give it a shot. All right, now that you've tried it yourself, let's go ahead and work it out. We're going to get rid of the subtraction first. The opposite of minus 3 is to add 3. So I'm going to add 3 to both sides of the equation. The minus 3 and plus 3 cancel, leaving me with 2h equals 17 plus 3, which is 20. Now I'm ready to get rid of the times 2. So I divide by 2 on both sides of the equation. Divide by 2 here and by here. 2 times 2 and divided by 2 cancel, leaving me with h equals 20 divided by 2, which is 10. Did you get it right? If you didn't, put in what you got and see about what you get on each side of the equation. You're not going to get the same thing on both sides of the equation. Our last example, give it a shot, and then we'll check it together. All right, now that you've tried it, we look at this and we see d divided by 5 plus 4. So we want to do order of operations backward. Take care of any additions and subtractions first. So we're going to do the opposite of plus 4, which is to subtract 4 from each side of the equation. Once we've done that, the plus 4 and the minus 4 cancel. So I get d divided by 5 equals 2. Then I want to get rid of that divided by 5. So to get rid of the divided by 5, I'm going to multiply by 5 on each side of the equation. So the divided by 5 and times 5 cancel. 2 times 5 is 10, so we get d equals 10. And if you go back and check, that does in fact work in this equation so that both sides will be equal.